Hi everyone. This video is just going to talk about slope as a rate of change, okay? Sometimes teachers use slope and rate of change interchangeably, if you don't mind the unintentional pun. So slope is rise over run, just like you have hopefully seen in previous videos. And again, I have videos on slope and what it is, and feel free to watch those if those are confusing. If I'm saying the words rise and run, you don't know what I'm talking about, it'd be good to at least watch the introduction first. Rate is almost the same thing as the slope when it comes to this stuff, but it requires units and it's expressed as a unit rate. And I have another video on unit rates. A unit rate is when you have something out of one thing. So 24 kilometers in 1 hour is how we often talk about speed. Um, we don't really say 24 kilometers in 2 hours, for example. All right? So a unit rate is when it's out of one. You take the top and, well, I'll show you. Let's do that down here. Mary Winston Jackson is on a track team and she runs every morning. One day she ran 5 kilometers in 20 minutes. She ran 5 kilometers, okay, in 20 minutes. Now, this is not a unit rate because, the minutes is 20 here. And the only way to really come up with a unit rate is to figure out 5 kilometers in 1 minute, which is going to be a weird answer because we don't generally talk about speed per minute. But just for the sake of doing it, I'll do it here. If you take a calculator and you go 5 divided by 20, you're going to get 0.25, a quarter of a kilometer per minute. That is how fast she is running. She's running a quarter of a kilometer, or 0.25 kilometers in 1 minute. Okay, it's still very fast. It's the same speed as up here. It's just written differently. If you really wanted to, if you really needed to know her kilometers per hour, you could take the top and the bottom and multiply them by what number? 20 minutes multiplied by what would make 60 minutes? Because 60 minutes is an hour. If you tell me it's 3, you are right. So multiply 5 times 3 and 20 times 3, and you'll get 15 kilometers per hour. Okay? Now, I'm going to stick with this just for now. It's the unit rate, but I just wanted to show you. She's actually running 15 kilometers per hour. That is very fast. Okay, so what is the meaning of the rate of change in this situation here? Well, when it comes to this person, it is talking about her speed, okay? Her rate of change. How many kilometers she is going every, well, in this case, minute. So how fast she is going each minute. That is the rate of change, okay? So if we were to graph Mary's distance as it relates to time, if you watch the video I have on distance time graphs, you'll know that distance will go here on the y-axis, and on the x-axis here we'll have time. Because distance depends on the time. Distance is the dependent part, and time is independent. It just keeps ticking no matter what. So if we were to put, we have to figure out time along the bottom here. We're not talking huge amounts of time. Let's just go, I don't know. We can't go by ones though, so we'll go, I don't know, 5, 10. These are minutes, by the way. 5, 10, 15, 20, 25, 30. There we go. Sorry for the mess. It's very difficult writing like that. That is really a mess. Anyway, the distance here, well, let's talk about how far is she going. Well, I guess let's say 1 kilometer each time. So the distance will be in kilometers. 1, 2, 3, 4. There's the lucky 5. That's what she ran. 6, 7, 8. There's 10. And time is in minutes. It is a huge mess. I'm going to use a blue pen for this. So we know that she ran 5 kilometers, and she ran that in 20 minutes. So 20 minutes, 5 kilometers. I'm going to put a dot right here. And she started at 0. So at 0 minutes, she had run 0 kilometers. and here is our line right here. Okay, I'm going to draw that in. I know it's not a bad actually, not a bad line. Now, if we were to calculate, which I think they're going to ask us to do, calculate the slope of the line is the next question. Remember, the slope is the rise, this amount of distance right here, over the run. Okay, so the slope is the rise over the run. So the rise is 5, and the run is, be careful, don't count the squares, make sure you go by the units you see here, it's 5 over 20. So the slope is just 5 over 20. And slope, you can leave it like this, or if you really want to, you could say the slope is 0.25. But notice that we do not write in units here. No units. Slope doesn't have units. A unit rate does, or a rate does have units. So I wanted to emphasize that point to you. Okay? Slope and unit rate are so similar. Okay? So how is the rate of change related to the graph? Well, the rate of change, it's the slope, and you already know this answer, don't you? With a unit rate, or units. It's the slope with units expressed as a unit rate. Okay. As far as I know, that's all you need to know. But if you want to quickly go through this, we can go through another question, this time involving the volume of gas remaining in a car's tank. Okay, obviously it's a negative slope, it's going downhill. And again, negative slopes, that's another video where I talk about slopes. So let's look at this. It says there's 2 questions here, and this is the last page we're going to do today. Calculate the slope of the graph. Okay, well let's take the rise over the run. The rise here, if I want to go from here all the way down to, I'm going to say this is my sort of like a triangle. I'm going to call this the rise, and over here is the run. The distance from here to here, I'm just reading this right here. I see that 65. The rise is 65. That's liters, but I'm going to leave the liters for now. The run is 500 kilometers. Okay? If they're asking what the slope is, then I would just write, and I'll put it in yellow pen, it's easier to read, 65 over 500. Okay? We should reduce this fraction that we see here. If we were to quickly get a calculator and just quickly reduce this, well, 65 divided by, I know it can be divided by 5, is 13. Okay, and 500 divided by 5, see if you can guess that before I finish doing this. You should get 100. 13 over 100. We cannot reduce this anymore. This is our slope, okay? If we were to change this into a decimal, which you can do, you would just go 13 divided by 100, or you could have just saved time and went 65 divided by 500. You would get the same answer no matter which way you do it. So 65 divided by 500, you get 0.13. Now that makes sense because 13 divided by 100, well, whenever you divide by 100, you just move the decimal over 2 places. You get 0.13. But I just went 65 divided by 500 just to show that it's the same thing. All right, interpret the slope as a rate of change. So what does 0.13 really mean? Well, it means liters per 0.13 liters per, what's the unit here? Per kilometer. So this particular car basically uses 0.13 liters every kilometer. And that is a unit rate, okay? That is a rate of change. So this is our rate of change, and over here is the slope. Boy, are they ever similar. But I think by now you know the difference between the two, and you also know how they're similar. Hopefully that's crystal clear. I can only hope. Have a great day, everyone. Hope this video wasn't too confusing. Take care.